Hi there. I haven't done any videos for a while because I haven't done much to video, but I was trying to think of something I could do, and I thought I'd do one on this FM transmitter module. Now, they're on eBay from China, and they're only about £5 delivered, which is pretty impressive for what they are. Okay, you have to wait a few weeks to get it, but I don't know how they do them for the price, basically, and it's fully synthesized FM transmitter. It goes from 87 to 108 megahertz. Fairly low power output. It's specified plus 20 dBm on the listing, but that was a load of crap. It was the most I've got out of it, 7 dBm, and it does seem to vary. It's about 7 dBm at the top of the band and 2 or 3 dBm down at 87 megahertz. But it is what it is, and for the price it's pretty impressive. And it's got a few buttons on it, as you can see, and on the left we got a volume up and down button, then we got frequency which steps in 100 kilohertz steps, and we got a pause button which just mutes the audio, and it runs on 5 volts. And what does it draw? It draws 33 milliamps, which is not a lot. Turn it over, and it's got microphone capsule, which doesn't interest me in the slightest. I wanted it for stereo line input, and it did have 3.5mm stereo socket, but I don't want a socket, so I've just removed that, and I'll just connect onto the two connections when I use it. See the blob there? I found it was off frequency by about 20 kilohertz, which is maybe not a lot on FM, but I'm a bit of a perfectionist, so the crystal oscillator is just a crystal anyway. And I followed the traces out of there to the chip. I just stuck a capacitor on it, a 15 puff capacitor, and that brought it down to about 6 kilohertz off. In fact, I'll stick it on the counter. It was on 107, I think. Okay, you can see the counter. It's now 7 kilohertz high, which is acceptable, I think, on FM. I don't think many FM tuners would be too bothered about the offset. So yeah, so I stuck a 15 puff capacitor across one of the terminals of the crystal and brought it down. I don't think you could load it with any more than that, otherwise it would probably stop oscillating. That's what crystals normally do if you stick too much capacitance on them. But yeah, the reason I wanted it was I've got an FM DAB radio. Now, there's only, in my opinion, only one radio station in this country that plays half decent music, and that's Radio 6 Music. That's only available on DAB. So I didn't want to buy an FM tuner. I've got this DAB radio. It's actually in the bathroom. So I thought, well, it's got a line output facility in there. So I thought, I'll stick an this module, or actually it's another module I've got the same as this, but that's beside the point. Stick that in there and retransmit the signal on FM, so I can use it on my hi-fi tuner in the lounge, and also on my pocket radio, which I walk around with and in the garden, whatever, and with about 3 or whatever it was dBm output, it's going to cover the house and the garden quite successfully. And yeah, it does. It works fine. As I said, this is not the module I installed. This is just another one I've got, because I'm quite fond of these modules. They're quite useful. So that's what I've done, and it works very well. I can hear it all around the house, in the garden, halfway down the road, in fact. But there's one drawback with these modules, and one thing I'm not terribly happy with. The spectral purity is absolutely appalling. But I guess for what it is, and it does light up when you press the buttons as well, which is quite nice. What it is, I suppose you can't expect too much, and although it's only a couple of milliwatts output, 3 dBm, whatever, I don't like to put out spurious emissions, even though they might be about 30 dBs down on the fundamental. So anyway, I'll show you what it looks like on the spectrum analyzer. Okay, so I've got it connected up to the spectrum analyzer, and as you can see, it's producing 6.9, well, 7 dBm at 107. We'll just try it on 87, see what it's producing there. Just 87. Okay, peak search, 3 dBm at 87. As you can see, the spectral purity is absolutely terrible. It's got all this crap, which is, what am I on, 50 megahertz span. So marker, so even I was on 87 fundamental, and even on 88 it's got all this crap, and it goes out as far as 90, 93, 94, and it starts to drop off a bit. But I do a delta marker, so it's minus 30 odd dBs down at that point, rising up a bit here at 4 megahertz offset, minus 25ish. It's pretty awful, really. And also this horrible spike here, which is normal at 99 megahertz. So not only has it got a horrible load of crap near the fundamental, it's also got these spikes and another one down the other side. And it doesn't seem to matter what frequency you're on, it's just equally awful. That's on 75, that one. So I wouldn't use it as like that. I'll just try it on 107 again, see how much crap it produces there. Right, that's 107. Yeah, it's equally awful. Minus 20 dBm spike at 95. Peak is 7 dBm at 107. So how do I get around that way? This thing, doing all this, producing all this crap. Before I get into that, I'll just show you what a decent signal should look like from my signal generator, which is set to the same frequency and power output. Just unplug the transmitter, plug in the signal generator. Now, that's what a proper signal should look like. But, it is what it is. You get what you pay for. But I'm not going to use it. I wasn't prepared to use it, producing all that rubbish. So I basically built a bandpass filter, two-stage bandpass filter, and it's actually a helical filter designed, and it works very well. I'll get on to that in the next part of the video. And also, of course, you've got to consider the harmonic output as well. If I set it to second harmonic, which is twice 107, what am I on? 107, yeah. 107 is 214. Frequency 214 megahertz. There's the second harmonic, and that's not far off the DAB frequency for the BBC multiplex, which is 225 megahertz. So if you got this transmitter in your radio rebroadcasting on 107, that harmonic is going to overload the front end and knock out the DAB, knock down the sensitivity of the DAB tuner in the radio. So that's another good reason for using a bandpass filter rather than just a low pass. That would knock out the second harmonic, but it wouldn't clean up the fundamental. So here's the basic filter design I used. It's metal box made out of copper, I think it was, quite small, not even as big as what I've drawn, about an inch roughly square. And we've got one coil here with a tap on it at the low impedance end for the input, and it's tuned with a roughly 10 pf capacitor, and then it's a metal shield through the middle so they don't couple, these coils. And this is the output coil, which is identical, tuned again with 10 pf roughly. I had to experiment obviously with the number of turns and all that, and it's tapped at the low impedance point to the output. And this metal shield in the middle has got a small hole drilled in it, and I'm coupling basically with a small, very short piece of wire that goes in from one side to the other. So it's acting like a capacitive coupling between the two coils at the high impedance point. Then you've got a trade-off then. If you couple too much to get maximum output, then you broaden the filter's bandwidth. So ideally you want to try and keep the coupling capacitor as low as possible. Makes the filter as sharp as possible, because the more coupling between the two, the lower the Q of the coils. So it's a bit of a trade-off. So I think roughly I'm losing about a couple of dB, 3 dB maybe, but that's not a problem. I don't want a massively big signal anyway. I only wanted to cover the house and the garden, and I want the sharpest filter I can produce to get rid of all that crap I showed you on the spectrum analyzer. So what else can I say? I think I got this design off the internet. I can't remember where I got it from. I used it years ago when I was making filters, and it works quite well. And of course, as well as cleaning up the all the crap that was either side of this signal, it gets rid of the harmonics as well, which is ideal for what I'm trying to do. And it's roughly 50 ohm input, 50 ohm output, and that's basically it. So I guess I could show you the final design. Okay, so here's the DAB radio I used. It's quite a nice little radio, pure Tempest, whatever it is, and as you can see, it's tuned into BBC Six music. Okay, but if I turn it around, wow, as you can see, it's got two aerials. One's the normal one that's for the DAB. I'll turn it around, and it's a DAB aerial plug socket, and that's the one I've put on it for the FM transmitter, which is inside it. And another good thing about this radio and also the transmitter module is their non-volatile memory. So if you get a power cut, the transmitter remembers it was turned on and comes straight back on again when the power comes on, and also the radio does the same thing, so you don't have to worry about turning it on and messing around inside or anything like that. So that's quite good. And yeah, I'll just open it up and show you the installation. Okay, so this is the installation. That's the transmitter module, obviously, on 107, and this here is the filter. You can get a close-up of the filter, and input coil. The output from the transmitter goes into that coil, and there's a piston trimming capacitor, which are quite good quality actually. They were PTFE ones, and the same on the output. And I don't know if you can just about see the coupling wire that goes through the hole in the metal divider. So, and then that's connected to this extra socket which I put on the back here. I conveniently had a piece of aluminium to bolt it all onto. Well, bolt the socket onto. This is just stuck down with double-sided foam, and it all fits in there very nicely. And there's a convenient line level stereo output, which is a 3.5 stereo socket on the back. I've just wired it into the module on that little bit of cable there, and it runs on the convenient 5-volt regulated, off a 5-volt regulator, which is in the radio. It only draws 30 odd milliamps, so it's not going to overload the regulator or anything like that, and it all works very nicely. So I'll just put it all back together and then stick it on the spectrum analyzer, and you can see how relatively pure the output is now. Okay, it's now wired up to the spectrum analyzer. I took the arrow off the back and wired it straight into the spectrum analyzer. We'll be on 50 megahertz of division span and 107 megahertz, and it's peaking at 3.8 dBm output, so that's reasonable. I don't want any more power than that, but as you can see, it's cleaned it up considerably compared to what I previously showed you. The spectral purity is fairly good now. I mean, if I do delta marker, that's 45 dBs down at 1 megahertz offset, and I go down to 4 megahertz offset, it's 60 odd dBs down. So it's made a hell of a difference putting that helical filter, bandpass filter, in it. Go back to the other side and it's about the same. 4.2 megahertz offset on the low side is 59, 60 dB down. Mark our normal span, expand the span a bit. It's still a bit noisy, but really I think it's as good as I'm going to get it, and a hell of a lot better than it was before. If we look for the why have I got 30 dBs of attenuation in there? I shouldn't need all that. Oh yeah, because I'm on 10 dBm reference level, that's why. If we look at the second harmonic, which is 214, I expect to see not a lot. Not a lot at all. Okay, I can lower the span. There's nothing there. Reference level. Okay, here we are. So we've got our second harmonic is minus 70 dBm. That's pretty bloody impressive for a simple little filter like that. That's about nearly 80 dBs down on the fundamental. No, 73 dB. But anyway, it's still pretty impressive. I don't think there are any more things to worry about. No, 50 megahertz. There's no other spurious signals at all. There's back to the fundamental. No, there's absolutely nothing, no other crap at all now. So it's made a hell of a difference putting that helical filter in it, and it's now what I would consider to be acceptable, and it's not going to cause any trouble or any interference. So I think the final thing to do is listen to it. Okay, this is it's all back together, and as you can see, 2 aerials extended, and here it is on the tuner. And that's rebroadcasting DAB on 107 megahertz. So because I don't have to keep it on that channel, I can always have a different radio station rebroadcast. But as I said, BBC Six Music's probably the only half decent station in this country, in my opinion, apart from Radio Caroline, and that's too crap a signal over here because I'm 100 miles from where they're broadcasting from. They're only using a kilowatt, not like the 50 kilowatts they used to use on the ship. So that's a waste of time here. So anyway, that's about the end of the video. I hope you found it interesting. Thanks for watching. Bye.